Hi everyone, my name is Diego and this video will be strictly practical. We're going to apply all theoretical concepts we learned in the other video I made. In this video we will see how to apply stress tests in order to reach the breaking point of a service. We will improve that service without adding more servers, therefore without paying more money. I remember you that here in the right upper corner section you will find a link to subscribe to my channel. In my channel you will find a lot of practical videos. Don't worry if you see a lot of videos in Spanish, I've been translating those videos. Well, here in the bottom section we have Jmeter, a tool of money that is commonly used to stress a service, and in the upper section we have a single server with Nginx, php-fpm and MySQL. Also it has varnish, a cache layer. But now as you can see, the service has been stopped. So the service is stopped, as you can see. We have our server here. So we're going to start only with 20 requests in order to find out the average response time in normal condition. Not really normal condition, maybe isolated condition could be better. So we can see here in the upper corner section you will see a lot of php-fpm process appearing, and the test has ended and we have the results. The average time response is acceptable, not excellent, but it is a starting point. That is because I am using a relational database. If I had used a non-SQL database, that times would have been better. But in terms of an end-use experience, waiting less than a half second could be acceptable. And now we're going to try something different, more related with real condition with these servers by increasing the number of requests. So we're going to these servers. Sorry, this server, by the way, is the cheapest server. It only costs $5 per month. We're going to increase the amount of configured requests until we reach the breaking point. I had done this exercise before, recording this video. Hence, I know this server supports around 300 to 400 configured requests. Thus, we're going to shoot 350 configured requests, as you can see here. We notice here the stress of the server. The server starts to struggling with this number of concurrent users, and we have response time around 16 seconds, and that is a worrying number. We need to be careful when the server starts to slow down like this, because probably we're reaching the breaking point. We are only shooting a burst of concurrent requests, but keeping for a long period of time the same amount of requests per second is a completely different story. In order to keep this video short, we are going to use only a small burst of concurrent users. Well, now let's increase just a little bit the number of concurrent requests. Despite 300 requests per second is not a bad number. If we keep a constant amount of concurrent requests with this server, it will be around let's see, 200 requests per second in a minute. That will be 12,000 requests, and in 1 hour near 1 million of requests. And only paying $5 per month, that's not a bad number. So let's start our test with 400 requests in 2 bursts. Let's start. We notice that the server doesn't support this amount of requests, and here we have a high error rate. 87% of the request has failed. And here we can see a totally broken service. we can make some conclusion right now. For example, the breaking point of the service is around 350 concurrent requests. What would be the normal choice here? It might be add more servers and put them behind a load balancer, but that is not the idea because we don't want to spend more money. Fortunately, we have an option now. Remember the other video in which I talk about how to reduce cost separating the static from the dynamic part of a system? This service is part of the static because it's showing a list of items. Therefore, a list of items could be cached in a period of time. So let's start with varnish cache layer. You have more options like Akamai or Clifford, but if you don't want to pay more money, this will be the best choice for now. Our varnish cache service has been started, and we could start the test again with 400 concurrent requests. But first, let's check what happened with 350 concurrent requests. We did the same test at the beginning of this video, and we saw a really slow response, near 16 seconds. Let's try it. Let's one moment, please. Oh, let's wait a minute, and that's my fault. Sorry for that. Varnish is listening in another port, and it is redirecting to another internal port when the time to live ends. I only change the port, and you will see here in this console how the server handled the request. It only took 3 seconds to handle 700 requests. And we have still acceptable response times. Remember that in our last test we had times around 16 seconds, and now the times are below 2 seconds. Also, we notice the server doesn't make a real effort to handle these numbers. Let's try again with 400 requests and see what happens. We still have 0% of errors and response time below 3 seconds. So the server is still responding in a good manner. I have here an assertion to check if the response from the service is behaving as expected. If you want to make your own test, I'll let you the link to the repository of this service with the varnish configuration. We reach our goal. We reduce cost because we can increase the maximum amount of concurrent users in our server without paying extra money. That is important. So that is what I mentioned before in the other video. I am feeling optimistic, therefore I'm going to increase the concurrent request to 700. And see what happens. Here we have a rate of failure less than 3%. Despite we have response time near 7 seconds, that is far away from the 16 seconds and 400 concurrent requests from the previous test without varnish. As I said before, you need to pay attention when the server starts to slow down because it is in the way to crash. We can repeat the test. And now we have a rate of failure of 10%. That is because the server has no time to recover from the previous burst. We need to wait for a moment. let the server go back to its normal state. And then just a little minute. If we repeat the same test, we will find out interesting information. Now, for example, we have a failure rate of 5%. But the server is not crashing. The server could handle the burst. Now we're going to reach the breaking point again. Let's try with 1500 concurrent requests. Remember that we ran a test without a cache layer and the server didn't handle 400 concurrent requests. Also, we had a failure rate near 90%. So let's compare our service with this cache layer. Here we can see our $5 server still can handle more requests, and we want to keep this video short. Thus we are going to increase the number of concurrent requests to our more demanding number. Let's say 4,000. That is 10 times more than the previous breaking point with the server without a cache layer. If you want to practice in your house, you have the tools, you have the repository, the theory. If you don't know the theory behind this process, you will find really interesting my other videos. You can subscribe to my channel if you want. Don't worry, you find a lot of videos in Spanish. I've been translating them, as I said before. Now we see the failure rate is acceptable. Is below 10%. Let's wait a minute. Here, yes. This is our final test. Our server is not collapsed and we still have a low rate of error, below 10%. We can handle more than 10 times of concurrent requests without crashing the server. This error rate is a value to consider. But your server is not blocked. You can enter your server, and in the worst scenario, only a very small amount of users need to repeat the operation. I recommend 0% of error, but for example, if you know that this doesn't happen very often, that is up to you. Remember to separate static from dynamic. Also, you can implement asynchronous processes. In conclusion, if we hadn't used a cache layer, we would have bought 10 more servers. In this case, our server only costs $5, but if you pay much more money and you multiply that value by 10, that will be a number to take in consideration. If you like one of my videos, please like it. In that way, I know that what are the best videos and I will make more similar videos. I invite you to subscribe to my channel. You have a link in the upper right corner. Don't worry about the Spanish videos. I will translate them. Thank you for your time, and I hope we can continue this process together. Sorry about the translation of this video because I made this video in Spanish and I was talking really fast in Spanish, so I have no time to translate this video quickly. Sorry for that, but well, that's all for now. Bye bye. Thank you for the time.